Hi, I'm Adolph Oliver, and this is the video on finding the LCD. Now, LCD stands for least or lowest common denominator, and it's what you have to have when you add and subtract fractions. Well, if you're looking at just the numbers themselves and they're not in denominators like the examples we have right here, then you would more technically call these lowest common multiple, but the method is exactly the same. And speaking about the methods, there are two main ones that are used here. One of them is the multiples method, and that's what you often do in your head, and I'll show you how you work this out on paper here. And then there's one called the prime factors method, which works better when you've got algebraic expressions. In other words, x's, y's, z's, things like that. Anyway, let's look at the first example here. What we want to find is the lowest common multiple, the lowest number that both of these guys will divide into. And one of the ways of working this is to write out the multiples of these guys. Well, this is what I mean here. Let's start out with the 35. And the first multiple of 35 is, of course, 35 itself. Now what you do is add another 35 to this to get the second multiple. That would be 70. Add another 35 to this to get the next multiple, 105. And you could, of course, keep doing that. Well, the same thing with the 10 here. Okay. The first multiple of 10 is, of course, 10. Add 10 to that, you get 20. Next multiple, add 10 more, you got 30. And then 40. And then 50. And then 60. And then 70. And of course, you could continue on there. But what you notice here is that we've now hit a common number in both of these multiple lists. 70, it's the lowest one in each. If you continue these lists, you'd hit other multiples, but they'd be higher, and that's not what we want. So our LCM or LCD, if these were in fractions, would be 70. Now, when you do this in your head, you shortcut a little bit of this process. Work with the larger number and think of the multiples of it. First multiple of 35 is 35. 10 does not divide into that. Second multiple of 35 is 70. 10 does divide into 70, so boom, there you are. 70 would be your LCM. Well, okay, let's look at another example here. 9 and 24. Okay, I'll take the larger number first, a 24. And let's work the multiples of it. The first one, of course, is 24. Okay, then you're going to have 48. Add 24 to that, you get 72. Add 24 to that, what do we got? I guess 96. Add 24 to that, you'll get 120. And of course, on that would go. Well, let's see what happens when we do with 9. Okay, 9, the first multiple, of course, is 9. Then we get 18. Add 9 to that, we got 27. Add 9 to that, we got 36. Add 9 to that, I think we're at 45. Add 9 to that, we'll get 54. Add 9 to that, we get 63. Add 9 to that, we get 72. Well, we could continue on out here, but notice now we have hit a common multiple in both of these, 72. Okay, so here we go. 72 would be our LCM or LCD. Now you notice when you get larger numbers here, a little further apart like this, this becomes a little bit more laborious to work out what it is. And that's why then we turn around and start making use of what's known as the prime factors method. So let me show you how this one works. Okay. Now you shouldn't be surprised that with a name like prime factors, what's going to happen is we are going to prime factor these guys. Now, you can use factor trees or any other method to do it. Many times you can kind of figure these guys out on your head. So for instance, 40 equals 8 times 5. Well, 8 is just made out of 2's. 2 times 2 is 4 times 2 is 8. So 2 cubed times 5. Now let's double check that. 2 cubed is 8 times 5 is 40. You could get this with a tree, but if you can figure it out in your head, that's perfectly fine too. The next one is 24. 24 is 4 times 6. Well, 4 is 2 squared. Actually, what it is, it's 8 times 3. Okay, because 6 is not a prime number. 8 times 3, we'd have 2 to the third again, and then times 3. Now let's check this out, make sure we're right. 2 to the third power is 2 times 2, which is 4, times 2 is 8. 8 times 3 is 24. Okay, I think we got it right now. 16 is going to be, I think that's just made out of 2's, isn't it? 2 times 2 is 4, times 2 is 8, times 2 is 16. Yeah, that would be a total of 4 2's. Now notice I've used exponents here to indicate how many of each of these prime numbers we have. And of course, all the numbers that we have here have to be primes. Well, how do you get the LCD or LCM from this? You simply do the following. Here's what the LCD would equal. Okay. You simply go back and look at all of the different bases that you have here. These are the main numbers, and they've got to be primes. You can see we have 2's, we have a 3, and we have a 5. You list them in the LCD down here if they show up one or more times. Doesn't make any difference if they show up like the 2, 3 times here. You only list it once, and the 3 and the 5 show up. So here's the first thing I do. I say, okay, the LCD is going to have 2's and 3's and 5's. Those are the different bases that you see. Now we go back and we take the higher power that we see for each of these bases. Well, the 2, I've got 3 twice and 4 once. 4 is the higher than the 3's. So what I do is say 2 to the 4th. The 3 has just 1. I mean, if you want to put an exponent of 1 here, you can. And the 5 is just 1 as well. Well, if you put this back together, this is going to be what your LCD is. 2 to the 4th is 16 times 3 times 5. Well, let's see what we get. Remember, you can multiply in any order you want. So I'm going to take 5 times 16 first, which will give me, let's see, I think that's 80. And then 80 times 3 would be 240. Okay, there is the LCD 240, okay, for all of those bases here, the original numbers 40, 24, and 16. We use the prime factors method. Now, 3 like this would be tough to do with multiples. That's where the prime factors method here starts to shine. Well, let's look at another example. Same thing going on here, but now what we're doing is we're looking at 9, 36, and 24x. We're introducing a variable in here, and the prime factors method takes care of this just fine. Again, prime factor each of these. 9 is just 3 times 3, or 3 squared. Remember, you have to use exponents. 36, we can think of as 4 times 9. 4 is 2 squared, and 9 is 3 squared. Now, double check this. 2 squared is 4. 3 squared is 9. 4 times 9 is 36. Okay, then the 24x. Okay, well, first the number. Okay, 24, we can think it was, well, we had it before, 8 times 3, and 8 is 2 cubed, okay, times a single 3. Now, what do you do with the x? Well, treat it just like any of the other bases. We also have an x here. Boom, there it is. Now, if I was to multiply all this back together, 2 cubed is 8, times 3 is 24, times x is 24x. Okay, so the nice thing about this prime factors method is it works perfectly fine if you've got some letters in here as well. Okay, what's the LCD going to be? Okay, well, again, take all the different bases. Remember, you only list them once, even if they show up more than once. So we see 2's, so I've got 2's. I see 3's, so I list 3. And I see x, treat it just like a base, there it is. Now remember, you go back and you take the highest power that you see for each of these bases. 2 is squared and cubed here, so it's going to be 2 cubed. 3 is first power here and squared in both of these. So the highest power we see for any of the 3's is squared. And of course the x is all by itself. You could put a power of 1 here, but let's just leave it as x. Now put this back together. 2 cubed is 8. 3 squared is 9. And then we have the x. Well, okay, if we multiply this together, 8 times 9 is 72. And we've got the x, our LCM or LCD for these 3 guys, the lowest common multiple that they all hit, 72x. Okay, well, let's look at some examples that have a few more variables in them here, because that, of course, is where we're going to end up going with all of this. So let's see if we can get this back here, looking at it. Okay, here's the first one up here on top. There it is. Okay, 12u squared and 30u to the 4th. As you learn this method, the variables are actually the easier things to work with. It's the numbers that take a little bit of work. So here's 12u squared. Okay, well, 12 is 4 times 3. 4 is 2 squared times 3. That gives me 12. And you look at how many u's you got. Well, 2 of them. So times u squared. Now double check this again. 2 times 2 raised to the 2nd power is 2 times 2. That's 4. 4 times 3 is 12. And we got 12u squared right on the button. Okay, the next guy. 30u to the 4th. Okay. Well, let's see. What can we do with 30? 30 is 6 times 5. 6 is 2 times 3. Those are the prime numbers that make up 6. So I think what we have here for 30, 2 times 3 times 5. And again, you could do that in a factor tree if you wanted. But now, what do we got here? 2 times 3 is 6, times 5 is 30. Now, of course, the only thing we're missing is the u to the 4th. Okay, well, what's the LCD here? We got everything we need now. So go back and list the different bases. I see 2's, I see 3's, and I see 5's, and I see u's. Remember, you put each base down only once in the LCD answer. So we got 2's, as we said, we got 3's, we got 5's, and we got u's. Now you go back and take the highest power that you see for each of these bases. Well, 2, the highest is squared. 3, both are to the 1st, so I can just leave it as a 3. 5 is to the 1st, so I just leave it as a 5. But now the u's here, I've got 4 here and 2 there. The highest power, exponent, is 4. So here it is. Let's put this back together. What do we got here? 2 squared is 4. 4 times 3 is 12. 12 times 5 is 60. So for the numbers, if I put them back together, I get 60. And of course, we've got the u to the 4th. So there's our lowest common denominator for these two guys. And the method worked with the variables just fine. Okay, well, let's look at one more example here with even some more variables in it. We got three guys here. We want to find the lowest common multiple. Again, it's not difficult to do. Let's take each one in turn. Here's the first one, 20x cubed y. Well, as always, the numbers take the most work. 20 is 4 times 5. 4 is 2 squared. So 2 squared times 5. Remember, you've got to break the number down into its prime factors. 2 squared is 4. 4 times 5 is 20. And these, of course, are both primes. Now, the variables are the easiest thing. Okay, we've got x cubed and y to the single power. You could put a 1 if you want again, but just leave it like that. That's good enough. 40x cubed. Okay, that's the next number here. Well, 40 is 8 times 5, and 8 we've seen before is 2 cubed. Okay, we'll check this here in a moment. 2 cubed. 2 times 2 is 4 times 2 is 8. 8 times 5 is 40. So there's the number, and the variable's easy. It's just x cubed. Okay, the last guy here we got 30 x cubed y squared. Okay, 30 is 6 times 5. 6 is 2 times 3 times 5. Now notice, again, these are all prime numbers, and they multiply back together to give you the 30. We figured them out in our head, but you could use a prime factor tree as well if you wanted. Now let's double check once more. 2 times 3 is 6, times 5 is 30. The variables now are the easy part. We've got times x cubed times y squared. Okay, well, in the prime factors method, the work is in prime factoring these guys. Once you get those set, however, finding the LCD or LCM after that is easy. Okay, let's see all the different bases we have. 2's here, 3 here, and 5 here. So 2's and 3's and 5's. And then I've got x's and y's. Okay, so there they are. Now, of course, we have to go back and take the highest power that we see at each of these. The 2's, first power here, third power here, second power here. So 2 cubed. 3 is just to the first power. 5, all of them are to the first power. X's, they're all to the third power. That's the highest of any of them. So, okay, x to the third. The highest power of y is squared. Okay, so there it is. All we have to do is just put it back together again. Let's see. 2 cubed is 8. 8 times 3 is 24. Actually, the easiest way to do this. 2 cubed is 8. 8 times 5 is 40. 40 times 3, 120. Remember, by the commutative and associative laws, you can multiply numbers together in any order. So if you see something easier, 8 times 5, I could do that and get 40 real easy. And then 40 times 3 is 120. That's legit. Now, of course, what else do we have? X cubed and y squared. Okay, so there we are. That's our LCD for these last three guys.